Hello, this is Mr. Stansbury. I'm going to take you through the 11E assignment. Alright, so we'll start with number 1 here. Find the total surface area of the following rectangular prism. So, we've got this rectangular prism here. So, a couple different routes you can take with this. Let's try this. Well, let's find the area of, say, the front and back. Okay, and then we'll also find the area of the, let's say, the left and the right. Left and right. And then we'll need to find the top and the bottom as well. Okay? Alright, so front and back is just going to be 5 times 1, right? So 5 times 1 for each of the front and the back. So that's 5 centimeters squared. Times 2 is 10 centimeters squared for the front and back. For the left side and the right side here, that's going to be 8 by 1. Alright, so 8 times 1 equals 8 centimeters squared. And we have both a left and a right, so we multiply that by 2, and that's 16 centimeters squared. And then the top and the bottom, so let's see, the top is 5 by 8. So that gives us 40 centimeters squared, but again we got 2 of those, so that's 80 square centimeters, and then we just add them all up. So 80, 90, 106 centimeters squared. Alright? Okay, let's move on to number 2. Find the total surface area of this. So again, you have to find, let's do front and back, because those are the same. Alright, so that'll take care of those. We could do the bottom, the left side, and then we're also going to find this top right side, so I'll call it top right. Okay, so we got to find all 5 of those and then add them all up. So, front and back, that's the area of a triangle, so that's going to be 1/2 of the base, which is 3, times the height, which is 4. So let's see, half of 4 is 2, times 3 is 6 square centimeters, but there's a front and a back which are identical, so that's 12 centimeters squared for those 2 sides. The bottom is 3 by 6, which is 18 square centimeters. The left side is 4 by 6, which is 24 square centimeters. And then this top right piece, this big piece here, is 6 by 5, which is 30 centimeters squared. So then we just want to add those all up, right? So 12 and 18 is 30, plus another 30 is 60, 70, 84. So it would be 84 square centimeters for that one. Okay? Alright, number 4. Shade house with these dimensions is to be covered with shade cloth. The cloth costs $4.75 per square meter. Find the area of each end of the shade house. Now, I'm assuming that must include the top triangular piece here too. So let's start with that. So we have the triangle piece, and we also have the rectangle piece right here. Okay, so the rectangle piece is 4 by 8, which is 32 square meters, and then the triangle is going to be 1/2 of 8 times 3. Base is 8 and the height is 3, so that half of 8 is 4. 4 times 3 is 12 meters squared, so we add those two together and that's 44 square meters for A. Okay. B, find the total area excuse me, to be covered with cloth. So again, we found the front. Says find the area of each end of the shade house. So each end is 44 meters. So those together, so we need to find the front and back. Right? So we find the front and the back, which is going to be twice 44. So that's going to be 88 square meters. We need to find the right and the left. Right and left, which is going to be, let's see, it's 4 meters by 25, so 4 times 25 is 100 square meters. Again, we want to multiply that by 2, so that's 200 square meters. Okay, so we've got the front, the back, the left, and the right. Now we just have to find the top two, so the top, left, and right. So those are going to be identical, and that's going to be 25 by 5, which is 125. Multiply that by 2, and we get 250 square meters. So we got to add that to the 200 to the 88. So that's what, 450. So we got 450 plus 88 gives us 538 square meters. Okay, so last part says find the total cost of the cloth needed given that 5% more than calculated amount is necessary for wrapping around the piping substructure. Okay, so we got to take our 538. And we got to find 5% more than that. So let's just multiply it by 1 for the 100 plus 0.05. That's the extra 5%. Right? So if we do that, then we will be able to figure out how much total we need to buy. So we got 538 times 1.05 gives us that we need to buy 564.9. So let's just buy 565 square meters. Right? So it's 475 per square meter. So times 475. So we'll do 565 times 4.75, and that gives us 26. Oops, I missed it. 2683.75. All right. Let's see. I'm imagining. Yeah, the back of the book just has 2683 because they probably didn't add on that extra tenth like we did. So we're good. That should work out just fine for that one. Okay. Let's take a look at the next one here. We got the total surface area of these solids. Okay, so surface area of a sphere is 4 pi r squared. So if this whole thing is 12.6, that means the radius has to be half of that, right? So 12.6 divided by 2 is going to give us 6.3 is our radius. So we're going to go, our surface area is going to be 4 times pi times 6.3 squared. Alright, so let's call that up and away we go. So 4 times, and again you usually want to find your pi button instead of pushing 3.14. It'll give you a more accurate answer. Times 6.3 squared, and we get 498.759. It doesn't say where to round it to, so I'm going to go 498.8. 498.8, and this is centimeters. It's surface area, so centimeters squared. Okay, next one we need to do is a cone. So the surface area for a solid cone is pi r s, where s is the slant height, and then plus pi r squared. So this is the area of the cone piece, and then this is the area of the circle down here. Okay, so our area is going to be pi times our radius. Half of 10 is 5, and our slant height is 12, plus pi times our radius is 5 squared. Okay, so we're just going to stick that whole thing in, and away we go. So we've got pi times 5 times 12 plus pi times 5 squared. And that gives us 267.03, so we'll go with area is 267.0. And that's going to be centimeters squared as well, because we're talking about area. Alright, and then the last one here that we're going to do is a cylinder. Okay, so that's going to be this one here with the the two ends. So our area is going to be 2 times pi times radius times height plus 2 times pi times r squared, and that's the two circles. This is the cylinder piece. Okay, so that's 2 times pi. Our radius here is half of 8.8, which is going to be 4.4, and our height is 15.6, plus 2 times pi times our radius, which was 4.4 squared. Okay, so let's plug that in and see what we get. Okay, so entered it all in, and we get 552.92, so let's go with 552.9. And that is centimeters squared for that one there. Okay? Alright, moving along. Let's try number 2. Find the total surface area of the solid hemisphere shown. So we got to find basically half of a sphere plus the circle on the top, right? Okay. Okay, so here's the area for the sphere. So we're going to actually want to take that divided by 2, right? Because there's only half of a sphere, and then there's the area of a circle. So and then we'll just add those two together. So we got area is, instead of 4 divided by 2 is 2, so we got 2 times pi, and our radius is 3, so 3 squared plus pi times our radius squared. That's the area of the circle. That's the area of the hemisphere. Okay, so let's put that in and see what we get. Alright, so there it is. I'll enter the calculator, and we get 84.82. So I'm going to go with 84.8. 84.8 centimeters squared should be the area of that entire thing there. Okay? Alright, moving on to the next one here. We got number 8. Find the total surface area of these solids. So we got a cylinder with height 3x centimeters and base radius x centimeters. Okay, so this is A. Let's try that one out first. Let's use that one too. So area is, let's undo this. Oops. Let me get rid of this. Okay, so we've got, now it's just, I got rid of my formula. Okay, here we go. So 2 times pi times the radius, which we know is x, times the height, which is 3x, plus 2 times pi times our radius, which is x squared. So we can simplify this as much as we can. So let's see, 2 times pi, so we got 2 times 3 is 6, and then we've got x times x is x squared, so we got 6 pi x squared plus 2 pi x squared, which should give us 8 pi x squareds for the surface area of that cylinder. Okay? Alright, let's do C here. A cone with radius 2x centimeters and a slant height of 4x centimeters. So we got to find our cone formula. So there's our cone formula. So we've got area is going to be pi times our radius, which is 2x, times the slant height, which is 4x, plus pi times our radius, which what they said was 2x squared. Okay, so area equals, let's see, 2x times 4x is going to be 8, and we usually put the pi after that, so it's 8 pi x squared, and then 2x times 2x is 4x squared, so that's 4 pi x squared. So we add 8 pi x squared to 4 pi x squared, and we get 12 pi x squared for our surface area of that one. Okay? Alright. Moving on to the next one, number 5. A wharf is to have 24 cylindrical concrete pylons, each of diameter 0.6 meters and length 10 meters. Each to be coated with a salt-resistant material. Find the total surface area of one of the pylons. So we need to find our surface area of a cylinder. So here's our surface area formula Okay, so let's plug in what we know here. So we got area equals 2 times pi. Our radius, our diameter all the way across is 0.6, so our radius is 0.3, and our height is 10, plus our two ends, which is 2 times pi times our radius, which is 0.3 squared. Alright, so now we gotta plug that part there into our calculator. Okay, so there it all is. Enter the calculator. We get 19.4. So 19.4, and this is all going to be meters squared. Okay. Part B says you got to paint the pylons, and the material that you or coat it is $45.50 a square meter. So we got to figure out how much it costs just to coat one pylon. So we got to take our 19.4, multiply it by 45.50, and then away we go, right? So we got our 19.4 times 45.50, and we get that it's 882.70. 270. So it costs $882.70 just for one pylon. That's a lot. Okay. Find the total cost for coating the 24 pylons. So we're just going to take our 882.70 and multiply it by 24, and away we go, right? So multiply that by 24, and we get 21,184.80. Whew, that's a lot. Oops, let's see, I missed that. 21,184.80. Okay, so that's just for coating the pylons. All right, the back of the book has 21,201 just because they had rounded this 882.70 to 883. So we are okay with our answer as well. All right, moving on. Number 8, height of a hollow cylinder is the same as its diameter. Write an expression for its outer surface area in terms of its radius r. So excuse me, if we draw this picture here, oops, it's basically saying this, that its height is the same as its diameter. So let's call the height x, and then the diameter is going to also be x. It does ask to write the expression in terms of its radius. So let's do this. Let's call, since this is x, let's call this just r, so then that would be 2r. Okay, so let's get rid of those. Let's get rid of those a little bit better way. Alright, so we've got radius and twice the radius for the height there. Okay, let's put this over in the right spot. So from here out to here is just the radius. Alright, so here is our surface area with a hollow cylinder, because it does not have the ends. So we got area equals 2 times pi times our radius, which is r, and then our height is going to be 2r. So area equals 2 times 2 is 4 pi r squared. Okay. Part B says find its height if its surface area is 91.6 meters squared. So now we know that the area is 91.6, and then we're going to plug. So we plug that in for A, and we set that equal to 4 pi r squared. Okay, so let's just divide both sides by 4 and pi. All right, so let's see, we've got 91.6 divided by 4 and divided by pi gives us 7.289 equals our r squared. So then we square root, and we get that r. So we square root our answer, square root our answer, and we get 2.699. So let's call that 2.7, and that's going to be meters for our radius for that. Okay. But that's not the final answer, because it asks for what's the height. So we got to take our 2.7, multiply it by 2, and that gives us 5.0 4 meters. Okay? So, that's not our answer. This one here is. Okay, last one. 9. Slant height of a hollow cone is 3 times its radius. Okay, so got a hollow cone, and the slant height, oh, so close. There we go. So our slant height, excuse me, is 3 times the radius. So let's call that R. So then the slant height is going to be 3R. Right? Write an expression for its outer surface area in terms of its radius. So again, this is a hollow cone. So here's our surface area formula. So we got area equals pi, and our radius is r, and our s is 3r. Okay, so we multiply those all together. Area equals 3 times pi times the radius squared is our surface area. Okay, so part B, find the slant height if the surface area is 21.2. So we'd put 21.2 in for our area, equals 3 pi r squared. So we divide both sides by 3 pi. Right? Another way to do that, instead of dividing by 3 and dividing by pi, we can do 21.2 divided by parentheses 3 times pi. So then it'll divide by both 3 and pi. That gives us 2.25, we'll call it. Square root both of those. Square root both sides, and we get 1.499, so let's call that 1.50 is our radius, and that's centimeters. Okay, the slant height is going to be 3 times that, so 1.5 times 3 gives us 4.50 centimeters is our slant height. Okay, and then C, find the height. Okay, so the height's going to be this right here as a straight line, hopefully. So what we want to do is do our a squared plus b squared equals c squared. Our c in this case is our slant height, which is 4.5, and that's squared. And then one of our sides is going to be 1.5 squared, and then we want to find the height, which we'll call b. Okay, so let's take 1.5 and square it, and that gives us 2.25. So that's 2.25 plus b squared, and then equals, get rid of that, our 4.5 squared. 4.5 squared gives us 20.25. So subtract 2.25 from both sides. We get b squared. So 20.25 minus 2.25 gives us 18. And then we want to simply square root both sides to figure out what the height's going to be. So we square root our answer, and we get 4.24. 4.24 meters should be our height for number 9. Okay? Alright, that's all there is here for 11E. If you have any other questions, please feel free to ask in class. Thanks.